Hello wonderful person, this is Anton, and today we're answering a question. Is there a possibility to have an explosion that's even more powerful than a supernova? And the answer to that is yes, and today we're going to be talking about such explosion that we've actually detected several times now. Let's talk about these unusual events, and welcome to What the Man. So I think by now most of us are aware that there are things known as supernova, basically these really large explosions that happen when a star sort of dies and creates this very bright and extremely powerful explosion that then starts the whole cycle again and creates new stars. A lot of the materials we have on our planet, including things that are inside your body, were actually created during such events. And so technically we're all basically a result of various explosions in space. But supernova are not the most powerful events. As a matter of fact, they are, despite the name, not as powerful as some other events, and specifically hypernova. Now hypernova have several names, including superluminous supernova and a few other acronyms, like for example SLSN. But the idea is quite similar, although the mechanics are a lot more complicated. As a matter of fact, as of today, we don't really entirely understand what actually causes some stars to go hypernova. There are a few things that make a supernova quite different from a hypernova. One of those things is actually the so-called gamma ray burst emissions. Now this is actually a pretty cool story, well, at least I think it's cool. Back in 1967, or basically in the middle of the Cold War, the US was trying to keep track of the Soviet Union and specifically their nuclear bomb tests that both US and Soviet Union were doing pretty much regularly at that point. And so US was actually trying to see if USSR was going to, or was trying to conduct illegal tests. And so they actually launched these satellites known as Vela Satellites. And here's actually a representation of such a satellite, and its only purpose was to try to detect gamma ray emissions coming off anywhere on Earth or even behind the moon, because some scientists or some politicians expected the Soviets to actually go behind the moon and try to detonate bombs there. And so these satellites actually did detect unusual gamma ray emissions coming from various locations, and so a lot of people really freaked out, and for about 30 years we couldn't really explain them. It actually was first explained, or I guess hypothesized, in 1997 when we actually realized that these gamma ray emissions were basically coming off these tremendously large explosions, and these explosions were probably very similar to supernova but way more powerful. And specifically here we're talking about these so-called hypernova. Now a supernova doesn't actually create gamma ray bursts, it doesn't create these very powerful emissions, but a hypernova, it seems, does. And we've actually detected at least a few such emissions in the last decade or so, and one of the most famous ones was only a few years ago, the event referred to as Assassin 15LN. Now, there's actually an even more powerful event that happened after that, but we're not entirely sure if it was a hypernova. But this particular event right here was definitely hypernova. And as you can see, the amount of light emitted was even brighter than the Milky Way. And so these events are extremely luminous, extremely powerful, and create these extremely powerful rays known as gamma ray bursts. But the most powerful event that we've detected so far was this, PS1 10ADI. You can actually read about it on Wikipedia, but just in summary, it was essentially a very similar event, but it happened very close to a supermassive black hole in an active galaxy. So we're not entirely sure if it was a hypernova or if it was just a star that was shredded by a black hole and that eventually just exploded, creating a lot of energy. Although it doesn't change the fact that it did create a tremendous amount of luminosity, it basically emitted a lot of gamma rays, and was very similar to other hypernova we've detected. Now, what exactly makes a supernova into a hypernova? Well, as you can probably guess, it's really the mass of a star. And here, let me just demonstrate by placing two stars. Betelgeuse, which is very, very popular for being a star that's most likely to go supernova relatively soon, in the next few thousand to possibly million years, soon by astronomical terms, of course, versus a star that will definitely go hypernova, R136A1. Much, much smaller in terms of size, but much, much more massive and much more powerful in terms of everything else. This right here is only, I think it's about, it says 11 masses of sun, so it's about 10 to maybe 15 masses of sun. This one here, however, is close to about 300 masses of sun, possibly even 350. So it's really the mass. The mass of a star determines if it goes supernova or hypernova. So this here, when it explodes, it will create a supernova. This, however, when it explodes, is going to create a hypernova, which will also have those gamma ray bursts. Now, in our own galaxy, there's one star that we're almost certain is going to create that kind of an explosion. It's actually a star that's very famous. It's a star I've covered on the channel before. It's known as Eta Carina. It's in the middle of the Homunculus Nebula, which is also in the middle of Carina Nebula. You can actually find it right here in Space Engine by typing Eta Carina, and there it is. So this star right here, a star right in the middle of a very, very bright nebula, is going to go hypernova. It's going to create a tremendously large explosion, and it's definitely going to create those gamma ray bursts. Now, as of today, we haven't really seen any hypernova in our own galaxy. As a matter of fact, we don't expect any because there are no stars that are as massive or as unstable as Eta Carina. But this right here will probably be the first example when it occurs. On the other hand, we actually may detect some other examples in a nearby galaxy. You may remember, or you may know about the Large Magellanic Cloud with the famous Tarantula Nebula. And this is actually the nebula where R136A1 is located. So right here, right in this region of space, if we actually zoom out a little bit, we'll find quite a tremendous amount of stars that are candidates for hypernova. There's at least 9 stars that have a mass of over 150 masses of sun, which is definitely more than enough to create a hypernova. And there's quite a lot of stars that have mass over 50 masses of sun, which is most likely a star that's going to create a hypernova. So this region of space right here, which is about 150 to 160,000 light years away from our planet, is going to have a lot of hypernova happening in the next few million years. We might be still around to see some. We might actually even be able to visit some and to explore them, depending on how we progress scientifically. But it's definitely the region of space that scientists are very eager to explore and very eager to study, because a lot of these stars are actually approaching the end of their lives, and a lot of them are going to be creating a tremendous amount of energy relatively soon in astronomical terms. And so this region of space is definitely going to be exciting to look at in the next few million years. But other than the Tarantula Nebula that you see right here, and other than the star known as Eta Carina in our own galaxy, there aren't really that many candidates for this very unusual event. As a matter of fact, we think that hypernova are actually very rare, and they only happen in a galaxy maybe every million years or so, or even less than that. As a matter of fact, even though we detect at least one gamma ray burst from a hypernova every single day, usually it comes from a random galaxy somewhere. So a galaxy might experience a hypernova only once per its lifetime. So these are not very common events. But this particular galaxy is lucky in that it's going to experience it several times. So Large Magellanic Cloud is definitely a pretty exciting neighbor to have. Anyway, so these events are, although unknown to us, are now a lot more well understood than they were only about 15 years ago. We definitely know a lot more about gamma ray bursts, hypernova, and also other energetic events that we've detected in the last few years. And hopefully in the next few years we'll be able to not just pinpoint such events, but also actually predict them before they even happen, so we can actually study them in even more detail. Well, anyway, that's all I want to talk about in this video, and hopefully now you know a little bit more about these events that are even more powerful than supernova, These events that only happen basically once per galaxy's lifetime. I'll see you guys tomorrow, come back tomorrow to learn something else, and subscribe if you still haven't. Click that bell button to be notified about videos, and also maybe even support this channel on Patreon because it does help a lot. I'll see you guys tomorrow, space out, and as always, bye bye.